We are going to talk about common factors with this video. Just a little recall about multiplying polynomials. If you have a monomial or something in front of a binomial or trinomial or a polynomial, then you're multiplying the front term by each term inside the bracket. So you would do 3 times 2 and then 3 times -5. And you would do the same thing here, but you have to keep in mind your exponent rules when you use the x squared. And as you see, you would get, for the first one, 6x minus 15. And for the second one, you would get 15x cubed because you have a 1 on the x in the front of the bracket. And then you would do x times x squared, which would be x cubed, etc. And you would follow along. So remembering that, we're going to move to factoring. Factoring is simply the opposite of expand and simplify. So what we are going to do, instead of multiplying each of the terms, we're actually going to divide, or essentially find the things that are common among each term. So that first question, 6x minus 15, we have two terms there. Terms can be things that have variables or numbers. So what we're going to do is find something that is common or can be divided into 6x and -15. And that would be, the largest common factor would be 3. So we're going to take the 3 and put it in front, and then we're going to have a bracket and think about what we just did on the previous page. 3 times what would give me that 6x. So we would need 3 times 2, and we would also need an x. So 3 times 2x would give me 6x, and then 3 times what would give me 15. So 3 times -5 would give me the -15. Or you could think backwards. 6x divided by 3 would give me what? Which would be 2x, and 15 divided by 3 would give me what? Which would be -5. And then you do the same thing here, but it just happens to be 3 terms. So 15x cubed and -10x squared and plus 20x. You have to ask yourself, what is common? What could be divided out of all of those? And the answer would be 5 for the numbers. And for the letters, the x could be taken out or divided out of all of those terms. So we're going to put 5x at the front. And then we're going to think to ourselves, 5 times what would give me 15? 5 times 3. And then, of course, we need to accommodate for that x cubed. So we already have an x to the 1, so we need an x to the 2 to get that x cubed. Then -10 divided by 5, so that's another way of thinking of it. Or 5 times what would give me -10, so I need a -2 there. And then x times what would give me x squared, so that would be another x. Plus 5 times what would give me 20. So 5 times +4 would give me a +20. And then we already have the x out front, so I am done. And then, of course, you could use your expand and simplify to check. So if you were going to, just in your head, you don't have to do it formally. In fact, you shouldn't do it formally because then it doesn't look like you factored. But you could just quickly go 3 times 2x would give me the 6x, and 3 times -5 would give me -15. So you know you're right without even looking at the back of the book. You can do a check quickly yourself. 5x times 3x squared would give me 15x cubed. 5x times -2x would give me that. And 5x times 4 would also give me that. So I know that I'm correct. Let's take that a little bit further. For these two questions, the only difference here is that we do have numbers and letters, but you'll notice that the exponents on the letters are a little bit higher than in the other questions. So for these ones, we are going to look at the variables, the letters, and see what the lowest exponent is that's common among all of them. So if you look at the very first question, which is 4x cubed y, that question there, you're going to first of all look at the numbers. So 4, 6, and 12, what number do they have in common, or what number could they all be divided by? And that would be a 2, so you could put a 2 out front. And then clearly x is shared among all of them, and y is also shared among all of them. However, we want to always pull out the greatest common factor. So the largest exponent on each letter is what we want to pull out. So if we look at the x variable on each one, we have x cubed, x to the 5, x to the 4. So the lowest exponent would be x cubed. So that's what we're going to put on our term at the very front. And then the y value, you can look at the y's there. And on the y's, we have y cubed, and y to the 4. Well, the lowest one clearly is just the y. So we're just going to leave our variables, our term at the front with just a regular y. And then we're going to put a bracket. And then we're going to think about if we multiplied this by each term in the brackets, you know, could we get those numbers at the top that we already talked about? So what number, 2 times what number would give me 4? Well, of course, I need a 2. X cubed, I already have an x cubed there, so that's done. And a y, I already have a y. So that's all I need there so that when I do my distributive law, multiplying, I would get that first term. 6 divided by 2, or we could think of 2 times what would give me 6. That would be a 3. We have x to the 3 at the front, and I need x to the 5, so I'm going to put x to the 2 there. And I have a y to the 1, and I need y to the 3, so I'm going to put y to the 2 there. And then on the last term, I need 2 times what to give me negative 12, so I need a negative 6 in there. And then x to the 3, I need an x to the 4, so I'm going to put an x in there. And then y, and I need a y to the 4, so this would be y to the 3. And then I close my bracket. And I'm done. That's all I have to do. Should always check inside your bracket, make sure there is no more common terms, but there isn't. But just in case you missed something, that would be a way to check. And of course, you can always check by using the distributive law. And if you did it right, you should end up with that. But you should not be putting that down here because then you haven't factored. Then you're just expanding and simplifying. But you could do that in your head or on another piece of paper just to check if you did it right. So you try this one. All right, now that you tried it, here's the answer. You're going to see what number and variable is common among all of them, so that would be a 3. It is a good habit to take out the sign of the first term, so we're going to take out negative 3. And then we have a that's common among all of them, and the lowest exponent on the a is the 4, so we're going to go a to the 4. And b is common among all of them, and the lowest exponent is just b to the 1. C is in the last one, but c is not common among all of them, so we can't pull that one out. Then we're going to put our bracket, and negative 3 times what would give me negative 15, so that would be a 5. We have a to the 4, so we need another a. We have b to the 3, so this is only b to the 1, so we need a b to the 2. And then negative 3 times what would give me 3? Well, that would just be another negative 1, basically, so we don't have to write a 1 in there, although you could if you wanted to. And then a to the 4. We already have, and b we already have, so we're done. So we do need that negative 1 in that case. And then for the third term, we would do negative 3 times what would give me positive 6, so watch your signs. So you would need a negative 2 to get that positive 6. And then a to the 4 we already have, but we need a to the 6, so we're going to need a to the 2. And then we have a b already, so that's good. We don't need a b, and then we have c. And you close the bracket. And again, you can quickly check that by doing your distributive law just in your head, not on the paper, and quickly check and see if you would end up with that equation. Let's extend this concept a little bit further. In this question, or in these two questions, you will see that technically we have 2 terms. Even though it almost looks like 4 or maybe even 6 terms, we really only have 2 terms. We have 3 times x minus 2, and then we have x times x minus 2. So those are all just one term. So what we want to do is look at this part here, the 3x minus 2, and this second part, which is the x times x minus 2. And we need to think to ourselves, what's common among those two? And what's common is the x minus 2. So just like in the last one, we take what is common and we put it at the front. So we'd get x minus 2 in a bracket. And then what is not common would go on the other, in the other bracket. So 3 plus x. Now, how could you check this? So that's the 3 and the plus x. That's how I'm getting that. So how would you check that? Well, you could expand and simplify this one, the very first question. You could expand and simplify that one there. And then you could expand and simplify that one and see if they're both the same. That's a lot of work. But if you had extra time, that's something you could do to check it. For the second one, see if you can do that. Give it a try. All right, so again, we see this as two different terms. That one there and that one there. And what we are going to do is look at what is common among both of those terms, and that would be x plus 1. So we're going to do that, put it in a bracket, and then the other two terms, the negative 2 and the negative y, would go in there. And you would have something that looks like that. And then we're going to do a final example, extending this idea a little further. These are two examples of factor by grouping. So we have 4 terms, and when we have 4 separate terms, we first of all always look for a common factor for all of them. And as you can see, there is not a common factor, whether it's a number or a letter, that's common among all 4 terms. So another way to look at it is to group it either in groups of 2 terms and see if there's a common factor, or sometimes you can even do 3 and 1. So we're just going to focus on working with groups of 2 and looking for a common factor. So if I look at the first 2 terms in this one and the last 2 terms in this question, you can see there is a common factor in both of them. So in the first 2, x squared and 2x, there's a common factor of just x. Sorry. So we're going to put the x in front. And then if I was just thinking about the 2 terms, x squared plus x, or 2x, I would need an x and a 2 there. And then if I look at the part that I underlined in blue, negative 4x and negative 8, the common factor there would be the negative 4. And I do want to pull out the negative, and that just makes it a little cleaner looking. And then in the bracket, I would have x plus 2. And now you can see it's like we just did on the last page. We have 2 terms with x plus 2 as the common factor. So we're going to put x plus 2 at the front, and then the x minus 4 on the inside. If we do the next one, you try the next one, and then I'll do it with you. So this one, I'm just going to do it in blue to separate it from the other questions. So I'm going to look at those first 2 terms, and the common factor would be a, and then I would need an a minus 3 for those 2, and then the common factor between the next 2, these 2 up here, would be negative 4, and again I would need an a minus 3, and watch that sign, because a negative times a negative would give me that positive. And then again, we have a common factor of a minus 3 and a minus 4 is the other 2 terms for the bracket. And that's a summary of using common factors in various situations.